Life expectancy has been rising about 3 months a year since the mid-19th century. We do well in Australia and are usually in the top 5 or 6 most long-lived nations. When we personalise this to the individual, though, life expectancy, which is a national average, becomes irrelevant. What many of us really want to know is how long we're going to live and how much of that will be in good health. Living longer is an obsession, and there are pills galore being offered to slow ageing and maybe even reverse it. Even so, the increase in longevity may be stalling, and you've heard a lot about that on the Health Report over the last 2 or 3 years, because our metabolic health is declining and our abdominal girth is increasing. So what works in slowing ageing? Well, that's been the life work, at least so far, of Luigi Fontana, an international authority on the biology of ageing and the dietary interventions, especially calorie restriction, which in fact is what many of the anti-aging pills seek to emulate without having to cut back on what you eat. Luigi Fontana is Professor of Medicine and Nutrition and has a chair in Translational Metabolic Health at the University of Sydney, and I spoke to him recently at length.
When I was a medical student, we had a professor in geriatrics who gave a very interesting lecture about the effects of dietary restriction in mice being the most powerful intervention to extend lifespan and health span. And so I was fascinated. I said, so there is something in mammals that is able to extend lifespan up to 50%. It is like for a human being, instead of living 80 years, to live 130, 140 years. The data back then, so we're talking about 25 years ago, were showing also a huge increase in health span with the prevention of cancer, cardiovascular disease, kidney disease, autoimmune diseases.
And before you go on, we should just define our terms here. So lifespan, just crudely, is how long you live. It's not, it's not life expectancy.
Yes.
It's just the absolute number of years you have on the planet.
Yeah.
And health span is how many healthy years you've got before disability and other diseases start to encroach on your life.
Yeah, absolutely. I wasn't happy, with being a practitioner where, you go to the emergency room because, there is a patient with a myocardial infarction, a stroke, and you try, to minimize the damage. I said, is it possible to understand if humans, like animals on calorie restriction, they live at least healthier and possibly longer if we can slow down aging and the accumulation of damage? And so I started to search, and there was nothing in humans.
And the important caveat here is it's bloody obvious when you think about it, but mice are not humans. Exactly. Although dietary restriction does span, they've shown it in fruit fly, in yeast, in other animal species.
In monkeys now, rhesus monkeys.
But the holy grail is humans, because humans are a lot more complicated.
Just to give an example, mice or rat, they live on average 2.5 years. Human beings, they live on average 80 years. Rhesus monkeys, that are primates, they live on average 26, 27 years. So even if they are primates, they live a third of what a human being nowadays lives. And so basically I started to search, and I discovered that there was a professor, John Holosy, in US at Washington University, who was starting a program on calorie restriction in humans. And he replied to me, say, come to US. So I took my luggage, and then I fell in love with what I was studying. John, he just died a couple of years ago, was one of the guys who discovered that exercise is increasing mitochondrial biogenesis, is improving insulin sensitivity, preventing diabetes. So he was a brilliant mind, a pioneer. And
we'll come back to mitochondrial biogenesis in a minute, because these are the energy sources in the cells, possibly the source of aging, and regenerating these and revivifying these mitochondria might be one of the answers for delaying aging.
Exactly. And I spent the next 17 years working on humans, research on calorie restriction. So we studied people who were practicing calorie restriction, so what is called technically a cross-sectional study. You compare these people with people who are master athletes or sedentary men and women consuming Western diets. And then we did 2 big randomized clinical trials, the Calorie, where we randomized people on calorie restriction. The first one, the Step 1 Calorie randomized clinical trial, was comparing people randomized to 25% calorie restriction without malnutrition, so with all the vitamins, minerals.
So what were the outcomes you're looking for? Because you can't hang around for 90 years to see whether or not they live longer.
Exactly. So lifespan is impossible. Even in monkeys, the monkey study, now we have finished it 20 years to get the data on survival. And so, it's feasible. But for humans, it's impossible. In terms of longevity, what we are trying to do is to develop biomarkers of aging, what is called biological aging. Can we measure biological age and with some biomarkers? Right now, the most common one, the most trendy one is epigenetic aging. So you measure DNA methylation, and there are some DNA methylation clocks that are...
So just to explain, epigenetic changes are not mutations in the actual DNA. They're chemical reactions around the side of the spiral of the helix, which change its shape and change its function. And this DNA methylation that you're talking about is one of these chemical reactions that changes the shape for better or for worse.
Yeah, exactly. And so basically these epigenetic changes is basically the regulation of which part of the DNA is translated into proteins. And what we have discovered is that what you do in your life, what you eat, if you exercise, if you smoke, if you're stressed, is changing the transcription of the DNA. And new data are suggesting that as you age, basically there are changes in this transcription.
Which may well measure your clock.
Exactly.
As opposed to how many days or months you've been on the earth.
Yeah.
It's really how many days or months affects your biology.
You can compare basically your chronological age, how many months and years you have been living, compared to the biological age. So you can be biologically younger. Let's say you are 50 years old, biologically you are 40, or biologically you are 60. And so these are experimental tools that, that we are training, we are working on, and it looks like they are good. And so ideally, we hope that in the next few years, we are going to refine these biomarkers of biological age, and then, we can do an intervention, can be exercise, can be diet, can be a supplement, can be a drug, and we can say, okay, your body has rejuvenated, or, if you're smoking or you have other unhealthy lifestyle, you have been getting older than your chronological age.
And what about the telomeres? We've spoken about that a lot on the Health Report. By the way, you are listening to the Health Report here on our end with me, Norman Swan. I'm speaking to Professor Luigi Fontana, a world authority on aging, slowing aging, the biology of aging. So we've spoken about the telomeres, these bits on the ends of the chromosomes, almost like the plastic bits on your shoelaces, to protect the chromosomes, which get shorter as you age, as each cell goes. And also that if you seem to have less damage of aging, they seem to be longer. Are they good as markers for aging?
Look, we don't use them in research. In the past, there was a lot of hope that good biomarkers, but Elizabeth Blackburn, who got the Nobel Prize for telomere and telomerases, she's a friend, and I sent her some samples of these people doing calorie restriction, and we don't see changes. And even in animals on calorie restriction, we are not able to use those as a biomarker. Doesn't mean that what you just said, that as you age, every time the cells are dividing and replicating, the telomere gets shorter. So no doubt about it. It's a real. I'm just saying that
it's not a good clock.
Exactly.
So come back to the trials now. What did the trials show?
So the first one, we compare people who were doing 25% calorie restrictions without malnutrition, or people who were exercising to increase their energy expenditure by 25%. And then, we had a control sedentary group. And we found that, of course, they were leaner, they had less visceral fat. Interestingly, both the CR and exercisers lost around 9% of their body weight and 40% on average of their visceral fat.
The dangerous fat in your tummy.
Yeah, the dangerous abdominal fat. And then we found improvements in inflammation, reduction in inflammation. We found improvement in insulin sensitivity.
And just again, so inflammation, which is really an overactive immune system which causes thickening and damage to your internal vessels, is probably part of the aging process.
Yeah, inflammation now we know is a key factor in the development of cancer, cardiovascular disease, stroke, and many other diseases, including aging. So it's one of the major players in aging and many chronic diseases. So we saw an improvement in insulin sensitivity. Insulin is very important because based on many animal models of longevity. So nowadays we can play with genes and we can knock down one gene or we can overexpress one gene in rodents, and then we can look what are the physiological or lifespan effects of this genetic manipulation. And so I will say the 80% of the animal models of longevity, meaning mice that are living longer than wild type, they have a mutation in the insulin IGF-1 pathway. So they have less insulin binding, less insulin transduction. And what we know is that as you get older, especially as you accumulate belly fat, visceral fat, because you are in a positive chronic energy balance, you are becoming insulin resistant. So there are a number of hormones produced by the adipose tissue called adipokines that are making the muscle, the skeletal muscle, but also the adipose tissue and other cells resistant to the effects of insulin.
And you get growth hormones that can stimulate cancer. So a lot of focus is on insulin. It's much more than diabetes in terms of how it affects the body.
A lot of people, they think about insulin when they talk about diabetes. In reality, before you become diabetic, you have many years of insulin resistance and hyperinsulinemia. So the beta cells of the pancreas, that are the cells that are producing insulin, they are trying to overproduce insulin to overcome the peripheral insulin resistance. And this hyperinsulinemia is driving cancer and aging.
So high levels of insulin.
Yeah.
So you got a signal that reducing calories by 25% seem to be doing similar stuff.
Exactly. So if we have to summarize, what we did find is that many of the metabolic hormonal adaptations that we have described in long-lived dietary restricted animals are also occurring in humans. So humans are adapting to calorie restriction similarly to animals. Another one, important one, we found a major reduction in oxidative stress markers, biomarkers like F2 isoprost.
This is biological rusting, which goes along with inflammation and drives those mitochondria that we were talking about as well.
We also saw an increase in autophagy, proteins and genes. Autophagy is another important mechanism.
So again, to explain, your cells get old and they should die, but some cells don't die and they just sit there causing havoc, and you want the body to get rid of them.
No, but that's senescence. Autophagy is different. So as we get older, we have accumulation of garbage in our cells because our cells, they are becoming less efficient to remove misfolded proteins, old mitochondria. So mitochondria, they get oxidized, they become dysfunctional. And so if you are in energy restriction, the cells, they are trying to say, okay, now where I get the material to create energy for cell functioning.
So they start to digest.
They start to digest the garbage. And so that's called autophagy. Instead of the other factor we found in humans as well is what you were saying before, cell senescence. As we get older, we have an accumulation of DNA damage. And when you have accumulation of DNA damage, that can be stimulated by smoking or radiation and many other stuff, you have two different options. One is that, this DNA damage ends up in oncogenes, you have cancer. Otherwise, this DNA damage can cause cell senescence. And what other colleagues have found is that these senescent cells, these old cells, these zombie cells, they are producing pro-inflammatory cytokines. So this is a major source of inflammation itself. They are also secreting pro-cancer factors. And we found that in humans and in animals on calorie restriction, there is a reduction in senescent cells.
So popular books out there being sold as the solution to aging, and I'll declare a conflict of interest here as I've got one coming out in August, but hopefully reasonably scientific. Let's just take fasting. So fasting's been touted as the answer here. And what they do is they say, look, if you look at fasting in animals, it prolongs their lifespan. It emulates dietary restriction. So if you look at the chemical pathways, I'll just use some technical terms like SIRT1, they recapitulate that and work in the same way. So what's your view on fasting as a surrogate for dietary restriction?
The story of fasting, really, at least the commercial part, started with the Michael Mosley documentary, Eat, Fast and Live Longer. I was one of the two characters on the documentary, and he came and interviewed me in St. Louis, and then he interviewed Walter Longo in Los Angeles. And back then, he put together a nice story, but without scientific data because there were no human studies. And even right now, the data on the effects of fasting, intermittent fasting or time-restricted feeding in humans, the data are very, very slim. I'm talking about humans. In animals, yes, the data are overwhelming that intermittent fasting is extending lifespan and health span.
But isn't there evidence in humans and larger animals that it increases aging, it speeds it up?
No, but we have data. I shouldn't talk about, but I give you just, we have a paper submitted now in a major journal for publication, and we were able to do intermittent fasting for 6 months plus 6 months. We see a beautiful reduction in body fat, in body weight and body fat, 8% weight loss. So it's very good for the standards of calorie restriction, but we don't see improvements in inflammation, no improvement in inflammation, very tiny improvement in insulin sensitivity and many factors. So despite they lose the same amount of body weight that we achieve with classical calorie restriction or with exercise, metabolically, we don't see the same responses. And why? Well, what we are finding is that a calorie is not a calorie, that the quality of the food you are eating influences the metabolic response to weight loss, okay? So the shortcut that people think, okay,
So if you're having bacon and eggs,
yeah,
it's not the same as a Mediterranean diet.
No, exactly. It's a balance between exercise, the amount of calories you are burning, and the metabolic adaptations that you are triggering with exercise, the quantity of calories and the quality of those calories. They are 3 pillars. It's like before, we were discussing about, these easy fix type of book or solutions that are very, very trendy. It's like if you go to the director of the symphony orchestra and you say, tell me, what is the most important instrument in the symphony? I don't know. He likes violin or cello. Okay, now I create an orchestra only with violin.
It's funny you say that. Actually, one of my chapters in my book says anti-aging is orchestral.
Exactly. We agree. So to have a beautiful symphony, to have I don't know if you like, Shostakovich, whatever symphony, or Mahler or Beethoven, you need a balance of all the instruments. If you have an overwhelming violin section, then you kill the beauty.
So then this translates to the individual substances that people say can influence the pathway, like resveratrol or NAD boosters, fisetin and so on. They should work, but they don't when you actually study them.
That's what is coming out. That basically in animals, in experimental animals, some of these molecules, not the one you mentioned, but, for example, rapamycin and others, they are extending lifespan. But we know, for example, that rapamycin in humans is causing type 2 diabetes, is causing immune depression. So if you are a mice who are living in a pathogen-free facility, well controlled in an environment where, you are not exposed to virus, to bacteria, then it may work. But if you are living in an environment like, we do, where, there is COVID and influenza and bacteria, then, some of these molecules are dangerous.
One of the things I'm interested in is the concept of homeostasis. So homeostasis, again, just to explain to the audience, is this balance. So you talk about the balance in the orchestra, and you talk about rapamycin, which is a fascinating substance discovered on Easter Island and taken back and having all these effects and used in people with kidney transplants to stop rejection and so on, is that when you look at aging, some people would argue that aging is a disruption of homeostasis. So we have a balance, and the balance, say we don't eat well, we don't get much exercise, we put on weight, the balance just tips towards aging. So it's like the Leaning Tower of Pisa, to use an Italian metaphor. So you have this Leaning Tower of Pisa, and then what happens, I'm putting a hypothesis to you, is that when you try and correct the Leaning Tower of Pisa to vertical, the whole body wants to push it back to a leaning situation because the body knows it needs a balance. If you're laying down protein and making substances, you've also got to break it down. If you put down fat, you've got to be able to lift it up and use it for energy. And so it's very hard to shift that balance. Does dietary restriction restore the disrupted homeostasis of aging? So in other words, the Leaning Tower of Pisa.
It looks so, even if the sooner you start calorie restriction. So the classical experiments, shows that, if you start dietary restriction without malnutrition, and let me reinforce that, without malnutrition. So going back to the idea of fasting, where people say, okay, I fast a couple of days per week and 5 days a week I eat whatever I want. That's dietary restriction with malnutrition. But in the experimental models, we found that, if you start, 30% dietary restriction in a very young animal, typically we were starting in post-weaning mice, you have an extension up to 50% of lifespan. If you start the same 30% dietary restriction in a 12 months old mice, that is equivalent probably to a 40, 50 years old human being, you have a 15%. 20% increase in lifespan. Because in those 12 months, that is like 40 years for a human being, you have accumulated damage. And yes, you can undo some of the damage, but not all of it. So the message is that at any age, you can improve your health by exercising, changing your diet, so counting your calories, controlling your calories, the quality of what you eat. But you cannot go back, totally to the same effects of when you started calorie restriction when you were younger. So the message is that the sooner you start to counteract the damaging effect of aging, because as you said, aging is a mechanism where the repair mechanisms are getting old. When you are young, you have a bone fracture and you're going to repair very quickly. When you are 70 years old, you have a bone fracture, you're not repairing. Or if you have a scar, when you're young, you're able, to repair very quickly the scar. When you get older, less. Because the mechanism, all these mechanisms, these autophagy, DNA repair mechanisms, the antioxidant mechanisms, the removal of cells, senescent cells, they get old and less efficient to keep homeostasis.
But there is still an effect.
There is still an effect. What I'm saying is that your trajectory of aging is deterioration of 20% of this mechanism per year. If you eat unhealthy, if you have excess belly fat, if you're not exercising, if you're smoking, if you're over drinking, you are accelerating the accumulation of damage and the deterioration of these mechanisms. Instead of if you are exercising, you're eating well, you're eating good quality, you're eating the right amount of calories, you don't gain too much belly fat as you get older, you are decelerating these mechanisms, and in some cases, you are rejuvenating cells.
So do you live a monastic lifestyle then?
No, I think it's not. Everything depends. For example, I exercise, I will say 1 hour, probably 5 to 6 times a week. And here in Sydney, it's beautiful because the weather is so nice all year long that, even in the winter, even at 6 p.m., I take my bike and I go for an hour. And for me, it's refreshing after one day, using my brain, going on a bike, and it's beautiful. So, 1 hour a day is out of 24 hours is not a lot. And then, I eat a very healthy Mediterranean diet. So very colorful, very tasty, with a lot of fresh fish. In Sydney here, it's, we are blessed. Lots of different type of vegetables, whole grains and beans. So I have a range of, I think, my diet is more diverse than many Australians or Americans because I have a lot of different recipes, very tasty. So I control my calories in 2-3 ways. One is, to eat a lot of unrefined food. So whole grains and beans and vegetables and fish. In this way, you are already controlling your calories. We did a study in US. Again, we haven't published, but, I'll give you the results. We are writing the manuscript right now where we fed people in a randomized clinical trial for 2 months a Mediterranean diet comprising basically whole grains and vegetables and beans and fish, poultry once a week only for 2 months. But I asked my dietitian to clamp the body weight. So if the participant was, let's say, 80 kilos at baseline, at the beginning of the study, I wanted the same person to be 80 kilos at the end of 2 months on this Mediterranean diet. We provided the food.
So that you could see the pure effect of the diet.
Exactly.
Rather than weight loss.
The results, they're going to be striking. But, just to tell you the results is that we had to overfeed people 250 calories to keep their body weight constant.
You're kidding?
Yeah. And it was designed to be isocaloric.
So it's hard work to maintain their weight.
It was hard work. They were losing weight like crazy because the high fiber diet compared to their typical American super refined, ultra processed food, it was already able, to make them lose weight like crazy. So this is a simple trick. You think about calorie restriction like, having these tiny portions, an empty plate. No. And I'm eating huge amounts of, if you look at my plates, are huge, big salads, very colorful, tasty, I do my dressing with orange juice or lemon juice with, pepper and this and that, a lot of spices. So you can be very creative. It's science-based, it's not just fiction, So that's number one. And then the other one is stop eating when you are 80% full. How you do that? Typically, we prepare these big portions and we have this plate full of food. And, typically you try to finish everything because otherwise you feel guilty.
As you were told by your grandmother.
You feel guilty to leave something in the plate. Instead of, one trick is, to do small portions, in your plate, you do a small portion, then, you are still very hungry. You need another small portion until, you reach a point where you say, look, maybe I would eat another 3-4 tablespoons, but I stop. I'm satisfied enough. I have a tiny of hunger, but, I'm satisfied. And that's a way, to restrict your calories. That's the second one. Then if you are overweight and you are trying to lose weight, then, you can use a third trick that is basically fasting, vegetable fasting once or twice a week, where you eat only...
Which is what the Greeks do.
Yeah, only raw or cooked vegetables, wide variety, non-starchy vegetables, with a couple of tablespoons of olive oil per day, because 1 tablespoon is 120 calories. And then, you can use orange or vinegar, whatever you want. And the fourth one is eating everything in a window of 6-8 hours. So in this way, if you put together high quality plus fasting or this 80% filling, you don't have to be a monk or to be, it's very easy, especially if you exercise, because we have clearly shown in this randomized clinical trial I was telling you at the beginning that if you lose weight, let's say 8% reduction in body weight with exercise or with calorie restriction, if you lose weight with calorie restriction, you have a reduction in T3, the 3-iodothyronine is one of the major active thyroid hormones. Therefore, you are lowering your resting metabolic rate. Whenever you lose, you are lowering your thyroid hormones, you are...
So you're burning less calories, fewer calories at less rest.
Instead of, if you lose the same amount of body weight and body fat by exercise, you have no reduction in T3.
So you balance the two.
Exactly. So basically, your metabolism is still very high. And therefore, it's mandatory to always couple exercise with diet. Otherwise, you are lowering your resting metabolic rate, and then you're going to regain, sooner or later, you're going to regain all your body weight and body fat with the interests.
Luigi, thank you. It's been fascinating.
You're welcome. Thank you for having me.
We'll get you back when these results are published.
Yeah.
So thank you very much. Luigi Fontana is Professor of Medicine and Nutrition and has a chair in Translational Metabolic Health at the University of Sydney. He has a book which came out in 2020. It's called The Path to Longevity, The Secrets to Living a Long, Happy, Healthy Life.